Dear learners, welcome back to the second session on conservation of resources and energy. One of the session of MSD 012 ecosystem and natural resources. It is part of program postgraduate diploma in sustainability science. So it continues to the that last session which we talk about environmental perspective of laws of energy and the matter, and then how resource was depletion, what is the pattern of resource depletion, and we talk about conservation of resources. So in this second session we are going to look into the energy conservation strategy, what we can do it, and we are going to talk about mineral scarcity, then expanding the that resource base related to mineral, recycling, resubstitution of minerals, and about art wisdom society in brief. The simplest and the cheapest way of minimizing energy crisis and other related problem is energy conservation. When you talk about energy conservation, it talks about the conservation of usable energy, not energy as a whole. If you are talking about energy as a whole, it is against the first law of energy. So, conservation of energy can be achieved by decreasing the energy wastage and increasing energy efficiency. For example, if you replace 100 watt incandescent bulb with a 25 watt CFL or lower watt of nowadays we have that LED bulb. So when you do not require any fan or light, you have to switch off that, right? This is some of the example. Then when we talk about this efficiency of energy, means increasing energy efficiency. That means when we are looking for increasing those energy efficiency, first hurdles with us is it will have higher initial cost. But if you look into longer term, by the course of saving by lower energy consumption, that have more weight than the cost, the higher cost you have use in the initial phase, right? So reduction in energy consumption does not mean in the same time a decrease in living standard, but use of energy efficient system. And when you use a energy efficient system, that may have a different qualitative lifestyle. At the same time, when we have decentralization of energy supply and production, particularly from alternative sources, that makes, for example, we are using the solar energy at household level, or this kind of approach makes energy self-sufficient. So when we talk about energy conservation, it is not only saving the energy or saving the non-renewable resources, it also reduces the environmental, ecological degradation. So that's why we're looking towards shifting to alternative energy sources. When we shift into alternative energy sources and following the energy efficient route, this also ensures carbon efficiency, means reducing carbon output per unit of useful work done. Let us try to understand how we have to improve energy efficiency and how we have to educate people about saving the energy, and how a government can play an important role in achieving those goals. So when we talk about improving energy efficiency, we know that there are many ways, like not converting, we should not convert or not converting energy from one form to another form unnecessarily. Means unnecessarily don't put your light on, unnecessarily don't burn your fuel wood, right? Simple example. Then reducing the steps of energy conversion, increasing the energy conversion efficiencies, minimizing transportation or transmission of energy, and increasing the efficiency of transport or transmission of energy. So all such kind of steps will reduce wastage of energy that occurs, that second law of that energy, that said the conversion of energy and transport and transmission. So decentralization energy production and transport transmission network and other planning tools, such kind of tools can help in saving the energy. So energy conversion and transmission, they sometimes made more efficient by simply readjusting the data and fine-tuning all equipment. Use of superconductors can dramatically increase the efficiency of all aspects of electrical energy use. Then, for example, we use the cogeneration method, that which uses spent heat of power plants along with electricity generation. This is also one of the way increase of energy efficiency. So the energy efficiency of many industry can be increased by using like recycled materials. We know that recycling saves energy than use of virgin material, right? So similarly, for example, when you talk about recycle of steel, an example, when we recycle the steel uses, then it uses only 14% of energy you would have used for processing that other raw material. Similarly, if you look about then 95% of energy saving is gained in recycling of the aluminum. So these are some of the examples. Then when we talk about how we have to give energy awareness, educating the people about the individual and that environmental benefit of energy saving, use of energy saving practices, that we need to encourage. But in most of the cases, what happened? In this also, the initial investment is very high, but if you look into the cost effectiveness of the energy saving system in the long run and cost cutting on the mental and physical health due to better environment, they are the incentives what we get out of that, right? For example, in some cases, like using that public transport system, it may not always be convenient. However, unless unavoidable, wherever possible unavoidable circumstances, except that unavoidable circumstances, we have to increase the use of public transport system. It will save a lot of negative environmental impact of resource use, right? Similarly, adopting a bicycle culture, it not only saves a lot of money on energy maintenance, it also promises a good health due to physical exercise and by ensuring a pollution-free environment. Utility companies also, they can also play a great role in energy saving without compromising their profits. They can produce energy efficient and durable products to reduce their investment in production of more electricity and pay for the environment and pollution directly or indirectly. That you can say that just kind of management pattern is called demand side management. So sometimes this utility company, they actively promote energy saving by giving some other incentive to the consumer. For example, helping consumer improve the insulation of their homes and use of high efficient energy like CFL, LED, while selling high efficient air conditioner and heaters. Besides making such efforts, that community and individual also must exert intense pressure on elected officials to develop national energy policy based on much greater improvements in energy efficiency and a more rapid transition to a mix of renewable energy sources. In coming to the role of the government can play, they should play a major role in increasing energy saving by influencing the energy market. First step is to set a positive example by using the most up-to-date energy efficient technology, right, by government in the government offices. At the same time, the government can fund and influence private agencies to fund the research and development of new energy efficient alternatives than their first consumer. The use of most up-to-date energy efficient appliances by the government, that will give a positive impact to the society. This can start the production and run the market, and the product then can reach the general public easily at a reasonable price. Now, government could simply mandate energy efficiency measure within their jurisdiction, though it may have some difficulty to take such a step. They should influence the fuel efficiency standard for vehicle, establishing energy efficient standard for buildings and appliances, greatly increasing government sponsored research and development to improve energy efficiency, and giving tax credits and exemption of government rebates for purchases of energy efficient vehicles, housing, building and appliances. You have seen such kind of initiative in India, right, that we have discussed when we discuss about sustainable development goals in the course 1. At the same time, when we talk about tax breaks and subsidies that can also be given to industries, individuals that are more energy responsible, right. Consumption of energy from non-renewable energy sources and the use of inefficient that appliances, they may be taxed heavily so as to include ecological, environment and health costs because of the use of such kind of energy sources. So, this tax will not only discourage such consumption, it increases the funds of the government which can be used for further improvement. So, different energy sources can also be taxed differently as part of their life cycle environment and impacts, so that it can shift us to rely more on renewable energy. For example, the public transport vehicle, they may get fuel energy at a subsidized rate than the individuals, right. So, another important way to improve energy efficiency is modify electric utility regulation, means through regulation, right. So, such kind of things we are also implementing in India. Then coming to, we talk about energy conservation. Now, we need to understand about mineral scarcity, how to deal with mineral scarcity. We know limited mineral resources is there. So, mineral scarcity can be dealt by adopting two major strategies. Number 1, expanding the resources base, means by locating new ore deposit or cycling all materials. Number 2, decreasing the demand for the substance by finding alternative of substitute for that particular substance, or simply eliminating the need for it through technological development, change in our lifestyle. So, these are the basic two strategies which we can follow to deal with mineral scarcity. This can be look into how to expanding the resource base, how to recycle, the substitution, durability and dematerialization of all those mineral sources. When we talk about expanding the resource base, it aims at exploring new deposits of mineral as one deposit depletes. So, the high-grade deposits that remain to be discovered are smaller, less accessible and more expensive to exploit, for example, under the sea. So, once the high-grade deposits are depleted, that more number of low-grade deposits can be explored. However, if you look into this situation, the quantity of metal dug from that mines, the disturbance in ecosystem, the energy input and the pollution cost for getting unit pure mineral will increase tremendously, right. Some of the few geologically common mineral like iron, aluminum, manganese, etc. That we can follow, and then higher grades ores are and such kind of that geological minerals they have that higher grade ore, their higher grade ores are very rare. But if you look into the lower grade of the ore, they are more abundant. In the same way, when we talk about the metals such as copper, tin and zinc, they occur either in geologically concentrated high grade, that mineable deposit, or with very low grade deposits of the high grade deposit. This hardly can be used. So, in such situation, the alternate part is decreasing the demand of those resources. And coming to the recycling, we talk about the recycling of resources and material in the last session. Today here, we are going to talk about recycling of those minerals. We know that recycling of material is one or other way to reduce our demand for extraction of virgin materials. It increases the stock of usable material virtually. For instance, a ton of pure metal at a recovery rate, of 80% gets stretched into 5 tons in effect. The recycle recovery rate is always less than 100% because there is wear and tear, rust and corrosion, and all those processes till it reaches to the finished product. Then when we are in use also. So a recycling recovery rate of 90% is extremely difficult for any of the metal. In practice, the current, if you look into the current recycling efficiency for many common metal, it is only approximately about 30% or less. The only material for which a higher rate of recovery is possible are precious metal like gold, because they are very non-reactive. And returning use item for collection, it is not enough because the recycling loop is closed. And when the recycling loop is closed, when it closes only if collected items are used again to make product that is repurchased. So the loop will often go unclosed if product made from recycled material costs more than the products made only from virgin resources. However, widespread recycling it's not occurring, very unfortunate, until it is economically feasible. The point is that we do not recycle unless it is economically feasible. So simply you pass the laws requiring recycling is not enough. Another reason of a frequent high price of recycled material and then virgin material is the cost of energy, including human labor, is very high. For example, mining and processing aluminum and many other metals are very energy intensive. Because recycling aluminum uses much less energy, there is strong cost incentive process, heat and closed loop. So in everyday term, recycling just one aluminum can save enough energy to run a television set for 3 hours. So this is the case of some of the metal like aluminum, right? But when you look into some other material, their energy and consumption and recycling is much higher than the process of production from the virgin material, right? In some material like newspaper and glass, it saves considerably less energy than recycling of aluminum. However, when we look into the human energy, such as process of collection, sorting the newspaper and glass, and the slim profit margin, this kind of slim profit margin will disappear. So one option is, the best option is to appeal to consumer to purchase recycled product, even if they cost more, to encourage recycling. To make it on a wide scale, society can levy higher green taxes on the virgin resources to boost the price of products made from them, so that a recycled product will be cheaper and loop will be close to consumer demand. Right, this is the answer what we have to do to increase the use of recycled material. Recycling uses energy, water, and such kind of recycles of resources in the same time is also not free from pollution. However, if we look into the energy requirement, it is much less. For example, we talk about aluminum, then the energy used in getting the same amount of material from raw material. So, if recycling extends the effective amount of substance from a number of years, the stocks will not sustain forever due to our consumption demand. Right. So, at times we may need to switch over to other substances for getting the same task, preferably renewable renewable resource. So that's why we're talking about substitution. At a point of time, As I told you, if there is not enough of certain material for coping with our demand, the only option remains is finding an alternative or substitute for it, which is similar to that properties. For example, tin can be substituted with aluminum and still for different purpose. So this substitute can also be found for many scarce materials such as lead, zinc and mercury. On the contrary, now in certain cases, finding a substitute is not possible due to unique properties of material, like platinum and other metal are used as catalyst in chemical process. Mercury is the only liquid and densest metal at elements, right? And they are absolutely necessary, and these are absolutely necessary in modern that metallurgy. So substitution for such kind of that material may not be an easy task, right? The other is plastic. We use plastic. It could be substitute a number of metal, but most plastic are derived from petroleum, which is non-renewable, rapidly diminishing resources. In such case, bio oil or other source coming from biomass could be used for making plastic. That is, and wherever possible, we should find a substitute whose stock is renewable in nature. Then coming to one of the characteristics of that resources is durability, right, and dematerialization. So another simple way to reduce the demand for mineral resources to produce durable goods that are designed to last as long as possible. This can be done by manufacturing the best quality of material and designing them in such a way that they could be repaired, rebuilt, modified, refurbished or used with other products. We can say interchangeable joint use in glasswares and so on, wherever required. So reuse of material can save a considerable amount of material, energy, money, food, drink and so on. These are some of the classic examples. Refillable glass bottles and these are some of the examples. Then another strategy to reduce the size of product where possible is the dematerialization. A smaller product, say car, may use less amount of material and energy for doing the same task than its counterpart. Means miniaturization. What that happen in electronics, they can also save substantial amount of raw material and energy due to their efficiency in material. Means if we have smaller size, terms of time, in terms of energy. But sometimes, the dematerialization process brings a lot of complexity in the design of product and incorporates such kind of materials like, alloys that may become virtually impossible to disassemble and recycle them when required. So, these are some of the limitations of this dematerialization, right? Then when we talk about sustainability, we're talking about recovery, reuse and so on, so practice. So this sustainability also counts or should count environmental cost. In the sense, what I'm trying to say is that when we are talking about sustainable approach, when we're talking about how to influence the people, we do not count the environmental cost when you are pricing a material or pricing a product. As we know that we are overuse the resources because they are too cheap. We pay the materials, timber, petroleum, many other virgin natural resources. But those, when you talk about, when look into their page, they do not count the environmental cost. That is one of the reasons it is very cheap and we are overusing that. Those environmental costs, we have already talked in the last few sessions also about 5 E's: aesthetic value, emotional value, environmental services, ethical values, long-term economic values. That is not counted when you price a product. So the price paid by consumer for natural resources are now actually omit this particular environmental cost. So we have to, consider all those when you are pricing a material, when pricing a product. Another way to incorporate long-term indirect costs is to use basic market principle. Consumer can demand sustainable products such as those made with recycled material. All environmental problems are closely intertwined with economic costs. It is very true of resources, most of the resources, because their extraction use are directly determined by their profitability. Destruction of resources and unsustainable activities are more profitable. That is why. So in many cases, if you look into from that angle, sustainable activities produce more jobs than unsustainable ones. So extracting resources are often mechanized and involves fewer jobs. Collecting used material and making furniture or any item from recycled or reused material would employ many more people than logging wood, etc. Similarly, tourism employs a larger number of persons. Auto repairs, which promote resource efficiency by ensuring consumption of less virgin materials for performing the same task, also promote much higher than the number of jobs than automobile manufacturing. Right, these are some of the examples. So one of the model when we can look for sustainable use of resources is kind of art wisdom society. We have discussed about the laws of matter and energy in this session, also in last session. So every individual resources they use automatically add some low quality energy in the form of waste and to the environment. So our individual use of matter, energy, resources and the contribution of waste in the form of heat, in the form of matter or pollution to the environment may seem small and insignificant. But this individual contribution is only one way. The inevitable 6 billion plus individual of the club, and each year there is an addition about 90 million newcomers. Means population is increasing. Increase in population created such kind of issues, right? So most of today's advanced industrialized countries, if you look into those advanced industrialized countries, we'll see their way of consumption is largely high waste or high throughput society style that attempts to sustain ever increasing economic growth by increasing the throughput of matter and energy resources in their economic system. So say here in this flow chart, you will see that this flow to the economics of society to planetary sinks where pollutant and waste are end up, right? So if more energy and material sources are used and wasted at an ever increasing rate, eventually the assimilative capacity of the local, regional and global environment will be exceeded. Thus, at some point, high waste or high throughput society becomes unsustainable. So, a stopgap solution to this problem is the conversion to a more sustainable metal recycling society from unsustainable high throughput society, right? This will allow economic growth to continue without either depleting metal resources or producing excessive waste and environmental degradation. So, it should be kept in mind that even though recycling metals have energy, alloy some amount of high quality energy is required, and it also adds waste heat to the environment. Along with development of a metal recycling society, lowering down the population pressure and a per capita consumption pressure on resource base is highly required for sustainability. Else, we must have an inexhaustible supply of affordable high quality energy and environment with an infinite capacity to absorb and disperse waste heat and to dilute, degrade waste matter, disperse waste heat and dilute and degrade, disperse heat. So, again, there is a limit to the number of times some materials such as the paper fiber can be recycled before they become unusable. So, this shift in resource utilization approach undoubtedly allow us to buy some time, but it is not a solution to more and more pressure on material resources base, even if all of them were somehow perfectly recycled. Some of the long-term solution to our environmental and and resource problem is to shift to a sustainable, low-waste society or art wisdom society. That is the way of society we have created. Here you will see this flow chart how we have to exactly following this. Have a quick look into that high quality energy, we have to then give a low quality heat energy and recycling and so on, right? This is exactly a sustainable low waste or algorithm society based on energy flow in the matter. So today in this session we talk about energy conservation and from the point of improving energy efficiency, energy saving awareness, role of government, and we look into how to deal with mineral scarcity, how to expand the resource base, how to recycle, the concept of recycling the minerals, its substitution, durability, dematerialization. At last, we talk about art wisdom society. So thank you very much.